Almost always, these questions start with having to work out the maximum mass, or what is known as the theoretical mass of product that you should be making when certain quantities of reactants react. Now, to do that, I'm going to use a methodology I've explained in previous videos, something called the 3-point process, and I've attached this PDF in the description below. So you need to get that first before we start this question. And also you need the periodic table and your calculator so we can work through this together. As explained in my previous videos, the 3-point process is a way of working out the maximum mass of product made using 3 steps. And it begins with circling the 2 things that are discussed in the question and then working out the moles of the initial substance you were given. So let's take a look. Calculate the mass of chromium that can be formed from 1.25 kilograms of chromium oxide. So it wants the mass of chromium that can be formed from chromium oxide. So they're the 2 things discussed in the question. And then number 1 in the 3-point process is to work out the moles of the substance you were given information on. So you will see that we're given the mass of chromium oxide, which I'm going to turn into grams, because the moles equals mass of our RFM formula always uses mass in grams. Moles equals mass over RFM, relative formula mass. The mass is 1250, and the RFM of chromium oxide is 2 lots of chromium, so it'll be 52 plus 52 plus 3 lots of oxygen, which will be 3 times 16 is 48. So your workings should look like that. Gives us 8.22368. Step 2. And the process says, compare the 2 things that are circled. Is the ratio 1 to 1, 1 to 2? And then work out the moles of the product or substance required. So we can see that the ratio of chromium oxide to chromium is 1 to 2. So therefore, if I want to work out the moles of chromium, all I need to do is times my previous answer by 2. Gives us 16.447368. Number 3, finally, now that we have the moles of the substance required, again, using the appropriate moles equation, work out what is asked for in the question. So I'm just reading from the guide. So it wants the mass of chromium. So mass is equal to moles times RFM. The moles is 16.447368. And the RFM of chromium is 52. And then timesing that together gives us to 1 decimal place. So that, if I just put that in red, what we just worked out there, that is the theoretical mass. Okay, that's how much we should be getting in a perfect world. If the reaction was using all of the reactants, there was 0 waste, the process was, perfect. And that's the amount we should be getting from 1,250 grams of chromium oxide. In reality, reactions are never 100%. Okay, there's always some sort of loss of product, whether that's in the purification process at the end or in how the reactants come together. There could be impurities in the reactants to begin with. So you never actually get the true mass that you work out on paper, which is this number here. So that sets up the last bit quite nicely. So it says 756 grams of chromium was formed in this reaction. So this amount there, that's the actual amount. That's how much was obtained in the experiment. So we should have got this, but we ended up with this instead. So the percentage yield is a really simple value to work out. It's just the amount obtained divided by theoretical amount, and then you times it by 100. And as I said, percentage yields are almost always less than 100% for the reasons I said. So all we have to do is do 756 divided by 855.3 times it by 100 to turn into a percentage, and that gives me to 1 decimal place, which is actually a really good percentage yield. So that's a really efficient process there. Most of the mass of the reactant is ending up as useful product, and that's a good conversion there. Okay, I hope that was helpful. Please check out all of the other content I've produced on molar calculations in chemistry. There's a lot of videos to get through, but I'm sure they're going to be of benefit for you. if you're revising for any upcoming tests or exams. If you've enjoyed today's content, please do like and subscribe. It helps me keep producing these videos. Otherwise, thanks for watching. See you next time.